Hi students, please welcome to the Physics Wala. In today's UMEED NEET batch, we are going to start the new chapter and also very important chapter, that is ray optics and optical instruments. Okay, and you know very well what is the weightage of this particular chapter. So whenever you observe the past 10 to 15 years, from the past 10 to 15 years, you can observe and you can say that from this particular chapter, ray optics and optical instruments, you are getting nearly three questions. Okay, therefore that is a weightage. So let us discuss about the first of all weightage of this particular chapter for your NEET entrance examination. As we just discussed, it is three questions. Overall from the optics, you can expect five questions. Five questions is not a minimum number of questions. Happily, you can score a very good marks from this topic, that is optics and ray optics. And before 2020 or 2018, the questions will be easy, moderate and difficult from this particular chapter. But whenever I observe the past 4 to 5 years, almost all the questions from this particular chapter will become are getting very easy. Okay, happily, if you learn what are the important points we are discussing in today's class or in this lecture, and whenever we solve the numericals based on that, I can say it is more sufficient. Happily, you can answer all the questions from the NEET paper, from the NEET upcoming paper 2025. Okay, I hope you are ready. Ready. So let us see. Let us start our session with the important points. We can call it as what is it? Synopsis. We can call it as a synopsis, and later we can go with the MCQs and with followed by previous years questions. Okay, so let us see synopsis are nothing but we can say the important points, what we have to learn and what we have to practice and what we have to keep in our mind to answer the questions from this particular chapter, Okay, so let us start our session with the thing. So one thing we have to very clear: how can we learn this particular chapter, ray optics and optical instruments? Usually it is a little bit lengthy chapter. Many of the people know that. Okay, so we have to divide this particular chapter into subtopics. What are they? We can say reflection by the mirror, and refraction through a plane surface, and also we can say refraction through a curved surface. In refraction through a curved surface, we will include the lens combination also, or the combination of lens, whatever it may be. And finally, we can go with the optical instruments, which include simple microscope, compound microscope, telescope, astronomical telescope. Okay, if you learn these things, it is more sufficient. Happily, you can answer any question. So let us understand the first topic, that is reflection by a plane mirror. Whenever we go with the mirrors are again classified into plane mirrors as well as the spherical mirrors. So first of all, let us understand about what is the reflection by a plane mirror. So what is the reflection here? How can we understand about this reflection here? We can say the phenomenon in which light returns to the same medium, after incidenting on a surface. Okay, is called reflection, is called as a reflection. Okay, so what is a mirror? We can say here mirror is nothing but anything which reflects the light, anything which reflects the light partially, completely, okay, is called as a mirror, is called as a mirror, okay. I hope you're understanding each and every point. From this particular topic, first of all, we have to understand about what are the laws of reflection. What are the laws of reflection, okay. So let us have an idea about this laws of reflection. You are all familiar. So let us consider a mirror. Let us consider a mirror and represent this mirror as a capital M, capital M. And if I draw a line, if I draw a line perpendicular to this mirror, and we can call this as, we can call this as normal. We can call this as a normal. So let us say IO is the incident ray. IO is incident ray, and OR is a reflected ray. Reflected ray. I am writing here ON. What is ON stands for? ON stands for normal. IO stands for incident ray. IO stands for incident ray, and OR is called as reflected ray. Reflected ray. Okay. So what is the first law of refraction? What is the first law? First law states that observe this incident ray, comma, reflected ray, and the normal at a point lie in a same plane. Lie in a same plane. You're all familiar with the first law of reflection. And whenever we go with the second law states that angle of incidence is equals to angle of reflection. Angle of reflection. What is this? I stands for, I is the angle of reflection. I is called as angle of reflection. Angle of reflection. And R is called as angle of, sorry, I is called as angle of incidence. I is called as angle of incidence. R is called as the angle of reflection. Angle of reflection. Okay. I hope you're understanding. So how can we measure this I and R? How can we measure this I and R? If we measure the angle, if we measure the angle between normal and the incident ray. See here, we have to measure the angle from the normal to the incident. We can call it as angle of incidence. And if we measure the angle between the, what is this, normal to the reflected ray, it is called as angle of reflection. Okay, there is a loss of reflection. Okay. Later we have to understand what is the deviation. Produced by a plane mirror. So please observe this. Whenever we consider a plane mirror, observe this diagram carefully. And whenever a ray of light is made to incident at the point O, IO is the incident ray. Suppose if there is no mirror, the light would have traveled along the dotted line, okay. But because of the mirror, the ray will get reflected back. Suppose, see here, I is the angle of incidence, R is angle of reflection. Therefore, if we measure what is the angle between the direction of the incident ray and the reflected ray, we can call it as a deviation. Deviation is always equals to 180 minus 2i. 180 minus 2i, or we can also say delta is equals to 180 minus 2r, because I is equals to r. Angle of incidence is equals to angle of reflection. Therefore, we can write the deviation is equals to 180 minus 2i. So how can we get it? So observe the diagram carefully. This total angle is equals to how much here? 180. So deviation is equals to 180 minus I minus r. I equal to r. Therefore, 180 minus 2i, or 180 minus 2r. That is about the deviation. Okay. So please think about this. For a plane mirror, we can say that. So observe this. Focal length is said to be infinity, and radius of curvature is also said to be infinity. Radius of curvature is infinity, hence focal length is also equals to infinity. Okay, and later we have to observe that whenever we consider a plane mirror, let us represent it as a capital M. So please look at the diagram carefully. And if I represent HI is the height of the image, sorry, HO is the height of the object which is located at distance of u, u. And if I get HI is the height of the image, which is formed at a distance equals to v, I. And for a plane mirror, we can say that HI is equals to HO, that is height of the object is equals to height of the image. And also we can say that image distance is equals to object distance, v is equals to u. What is HI stands for? HI stands for the height of the image. HI stands for height of the image, and HO is called as height of the object, and u is the object distance, whereas v, what is the v value here? V is the image distance, is it clear? Therefore, what is the magnification of a plane mirror here? Magnification, whenever we go with the magnification here, magnification is generally defined as size of the image divided by size of the object, that is height of the image divided by height of the object. Is it clear? Therefore, it is always equals to 1, okay. So please observe this magnification. On plane mirror, for a plane mirror, we can say that magnification is a 1, and for a plane mirror, image is always virtual. Image is a virtual image. Image formed by the plane mirror is always a virtual image. We have to keep that point in our mind. Okay. Later we can, whenever we move on to the what is it? Combination of the mirrors. So please have a look here. What is the combination? Or we can also go with what is the deviation produced by the mirrors, by the combination of the mirrors. So let us consider M1 and M2. M1 and M2 are the two plane mirrors which are inclined at an angle theta. Okay. So observe this. Whenever we consider a ray of light which is incidenting on the first mirror or second mirror, we can say it undergoes a multiple reflections. Is it clear? Therefore, what is the deviation? Produced? By the combination of the mirrors, which is nothing but 360 minus 2 theta. Delta is equals to 360 minus 2 theta. What is the theta here? Theta is the angle of inclination. Theta is the angle between the two mirrors. Okay. So like that, we have to think about this deviation produced by both the mirrors. Okay. So let us see. How can we calculate the number of images? So please think about this. Number of images formed here. Formed by the two mirrors. So whenever we consider an object, or whenever you place a material between the two mirrors which are inclined at an angle theta, they will produce the number of images. And we can observe, whenever we visit the shopping malls, or whenever we visit malls or whatever it may be. So whenever the two mirrors are inclined, at an angle theta, let us say M1 is one mirror and M2 is the second mirror, and let us say theta is the angle of inclination. So whenever we consider an object O, first of all we have to calculate the value 360 by theta. Okay. Suppose, see here, if 360 by theta is odd, odd, then we can say that number of images formed, n is equals to 360 by theta. If the value of 360 by theta is getting equal to odd number, then the number of images will be the same as that of the value of 360 by theta. This is the first point we have to make sure. And second point, if 360 by theta is even, then we can say that number of images capital N is equals to 360 by theta minus 1. 360 by theta minus 1. We can say like that. That is the number of images formed by the combination of the mirrors. Okay. And later, suppose if 360 by theta is a fraction, if 360 by theta is a fraction, then we can say that the number of images formed will be equals to the integral part of that fraction, For example, if you want, I can write my here. Suppose if we get number of images is equals to 5.8, that is not n, exactly. It is 360 by theta. 360 by theta is equals to 5.8. Then the number of images will become equals to 5. Number of images is equals to 5. Is it clear? So like that, we should calculate what is the number of images. N becomes equals to 5. We have to consider only integral part of the fraction. Okay. Now we have to think the next point. What is the next point? Suppose see here, if capital H is the height of a person, then the minimum height of the mirror, the minimum height of a mirror to see his complete image, will be equal to capital H by 2. Capital H is the height of the person. Then what should be the minimum height of the mirror, so that he can see his complete image? It should be equal to capital H divided by 2. There is a proof for this, but no one will ask the proof. We have to find out, or we have to learn only the conclusion statement. That is capital H by 2. Okay. I hope it is clear to you. Later, okay, these are all the points. What we have to learn from the concept of plane mirrors. Now let us move on to the next one, that is spherical mirrors. Whenever we move with the spherical mirrors are nothing but whose reflecting surface is curved. Okay. And under the spherical mirrors, we have to learn about the two types. That is, one is called as a concave mirror. And the other one is called as a convex mirror. Okay. One is concave mirror and the other one is a convex mirror. So please observe this. What is a concave mirror? How can we define this concave mirror? It is a spherical mirror. Okay, in which the reflecting surface is towards the center of the sphere. So please observe this. What is spherical mirror? It is a part of a sphere. In which the mirror is curved. So observe this. This is a center. This is called as a concave mirror. The mirror in which reflecting surface is towards the center of the mirror, we can say. And similarly, whenever we move the convex mirror, we can say that it is the mirror. This is the mirror in which the reflecting surface, in which the reflecting surface is away from the, okay, I will redraw this diagram here, in which the reflecting surface, in which the reflecting surface is away from the center, away from the center. So please look at the diagram carefully. This is the mirror, this is the mirror, and whenever we consider this, this is a center, this is a center of a spherical mirror, but in which, so whenever you consider this hand, let us imagine the white part of this hand is a reflecting face, and this black portion of the hand is a non-reflecting face, okay, or it is a hatched part, as a hatched part. So whenever we consider the hand like this, when I consider the hand like this, if the white face of this hand is towards the center, we can call it reflecting face. It is a spherical mirror. Suppose if the, see here, observe this, the white face of this hand is away from the center, then it is considered as a convex mirror, okay. So before going to see the few important definitions related to this spherical mirrors, let us have the sign convention, okay. So let us have the few important definitions here. Few important definitions. I will represent only important definitions. It's a very important thing we have to keep. Anyway, you have learned all these points in your 10th standard also. But anyway, so let us recap each and every point, okay. So whenever we consider a concave mirror, whatever the things we learn, the same things will be repeated for the convex mirror also, mirror also. So please look at the board carefully. The geometric center of the mirror is called as a pole, So please observe this. What is the pole? Pole usually represented by capital letter P. The geometric center of the mirror is called as a pole, So see here, the center of a sphere, of which mirror is a part, is called as a center of curvature. What is the center of curvature? Second one, we have to think about this center of curvature. But anyway, please make sure you are understanding each and every point here. Center of curvature, represented by C, And whenever we consider a line, which is passing through the principal axis, pole and the center of curvature is called as a principal axis, okay. And later we have to think about the third point, that is principal focus. We can consider as a principal focus. So what is this principal focus? How can we understand this? Observe this. The point on the principal axis, at which the ray which are incidenting on the mirror, will get reflected back, and it meet at a point, okay. That is called as a principal focus, capital F. Is it clear? And just observe the diagram carefully. So whenever we consider the distance between the pole and the center of curvature, we can call it as a radius of curvature. What is the fourth one we can say here? It is a radius of curvature. Radius of curvature is nothing but the distance between the pole and the center of curvature. Distance between the pole and the center of curvature is called as a radius of curvature. And whenever we measure the distance between, the principal focus and the focal point and the principal focus, pole and the principal focus, we can call it as a, we can say, what is a focal length, So please observe this. Focal length usually denoted by small letter f. It is a distance between the pole and the principal focus. So here, whenever we observe the ray diagram, so please note this point clearly. Whenever we observe the ray diagram in the ray optics, and when we study the formation of the images by the incident ray, all the rays we consider are paraxial rays or a paraxial rays. What are these paraxial rays? Paraxial rays are nothing but the rays which are incidenting near to the principal axis, or the rays which are incidenting on the mirror at very small angles, are said to be paraxial rays. Whatever the image formation we are studying, all the things related to paraxial rays. All the things are related to paraxial rays. Okay, I hope you can understand this sentence and word. Now let us understand. Let us understand about what is the sign convention. What is the sign convention? It's a very important here. Sign convention. How can we understand about the sign convention? So please make sure you are understanding each and every point. First point, we have to think that we have to consider this direction of the light. Direction of the light. Direction of light is taken as a reference. Is taken as a reference. Is taken as a reference, and it is positive, and it is a positive. Is it clear? So direction of light is taken as a reference, and it is taken as a positive. It is taken as a positive. Okay. And second point, all the distances, you have to learn as many times as possible, and you have to keep these points in your mind as a fixed points. All the distances are measured. All the distances are measured. Okay, from the pole we can say all the distances are measured from the pole. Okay, and third point, whenever we go with the third point, we can say that if the distances measured, if the distances are measured, okay, along the direction of the light here, if the distances are measured along the direction of the light, then they are taken as positive. Then they are positive. Okay. And third point, we can say that if the distances are measured, if the distances are measured, if the distances are measured, if the distances are measured opposite to, distances are measured opposite to direction of light here, the distances are measured opposite direction of light, then they are taken as negative. They are taken as negative. Then they're taken as negative. Is it clear? And later observe this, the distances, fourth point, I think fourth, yes ma, this is the fourth point. This is the fifth sign convention. It is the fifth point. We have to keep this in the point. If the distances, or we can say directly, the distances measure, the distances are the heights, the distances are measured, okay, above the principal axis, the distances measured above the principal axis are positive, and measured below the principal axis, below the principal axis are negative. Okay, these are the important sign convention we have to follow, especially while solving the numericals. Okay, so please keep this point here, and later we have to understand that what is the relation, between focal length and the radius of curvature is given by, f is equals to r by 2. F is equals to r by 2. And later we have to think that what is the mirror formula? Okay, so please make sure about these things. My mirror formula is nothing but the relation between the focal length, object distance, and image distance. We can say this as 1 by f is equals to 1 by v plus 1 by u. 1 by f is equals to 1 by v plus 1 by u. Okay, and please make sure about these things here. What is the magnification here? Magnification. What is the magnification? produced by the spherical mirror. M is usually denoted by height of the image divided by height of the object, and it is equals to minus V by U. Minus V by U. The basic formula we have to keep in our mind. What is HI? Height of the image. What is HO? Height of the object. And V is the image distance. U is the object distance. Okay. And here we have to make a very important thing, that is observe this concave mirror. Concave mirror is very dangerous, and we have to be very careful with the concave mirror. Why? Means concave mirror will form, concave will form both, what is that, real and inverted images. Here real images as well as inverted images, okay. So please make sure about these things. Here concave mirror will form both real images as well as inverted images. Sorry, inverted is not inverted. Sorry, this is a virtual images. We have learned what is the real image and what is the virtual image in the lowest sections. But anyway, real images are nothing but the images which can be caught on the screen, Is it clear? Real images is always inverted, virtual images cannot be caught on the screen, okay. So later we have to understand about convex mirror. Whenever we move with the convex mirrors always forms virtual and diminished images. So please make sure about these things. Here always forms the virtual and diminished images. So this is the point, and based on the sign convention, let us say how can we write the focal length, radius of curvature related to both the concave mirror and the convex mirror. So please observe this. For concave mirror, so please make sure about these things. Here for concave mirror, first thing we have to write, radius of curvature is taken as negative, and therefore focal length is also negative. Object distance is also taken as negative. Either it may be for convex or may be concave. Object distance always become negative, okay. And later please observe this. What can you say about the magnification here? Magnification, M is equals to plus M for virtual images, and no need to worry, they will be mentioning each and every point as a clue in a question, but we have to identify. Suppose we have they have not mentioned anything about the image, either it may be virtual or real, we have to calculate for both the images, okay. So magnification is plus M for virtual images, and magnification is minus M for real images, okay. So please take care of these points clearly without fail. Magnification is when it is taken as positive and when it is taken as a negative. This is sign convention we have to keep in our mind without fail. Okay. Now whenever we move on to the convex mirror, for convex mirror. Whenever we move on to the convex mirror, we can say first one, radius of curvature is taken as a positive, and focal length will also become equals to plus R, and object distance, I said already to you, object distance is always negative, either it may be for convex or it may be for a concave, okay. Only in one case, object distance is taken as a positive. What is that case? It is nothing but for, the converging beam of light. If we consider the incident light is a converging beam, In that situation, we'll take the object distance as a positive, because in that converging beam of light, the object will act as a virtual object, okay. And later we can go with the magnification. Magnification is equals to plus m, always it is equals to plus m, because convex mirror always forms virtual images, is it clear? So like that we have to think each and every point. And finally, whenever we go with the final conclusion statement, we can say that it may be, observe this, focal length of a mirror, it may be a plane mirror, concave mirror or convex mirror. The focal length of the mirror will not change, focal length of the mirror will not change in any medium. Is it clear? We have to make sure about these points clearly. Suppose if I take this mirror, either a plane mirror or a concave or convex mirror, into any other medium like oil medium or water medium, then the focal length of the mirror will not change, okay. So please make sure about these points and learn as quick as possible and practice this as many times as possible, okay. So these are the important points we have to learn under the concept of mirrors, reflection by the mirror, okay. Now let us move on to the what is the refraction, Mahir? What is the refraction of the light at a plane surface? Refraction of the light at a plane surface. First of all, let us understand about the refraction of the light at a plane surface. So please have a look here and note down each and every point. What is the refraction here? Refraction is nothing but the bending of the light when it travels from one medium to another medium. So observe this. When the light travels from, or we can say that simply, I can say bending. We can call it as bending of light, bending of light when it travels from one medium to, when it travels from one medium to another medium, okay, is called as a refraction, And one more point we have to understand that when light travels from, when the light travels from one medium to another medium, we have to make a note of this point. When light travels from one medium to another medium, we can say that the speed of the light will change. And wavelength of the light will also change. As well. But the frequency will not change. What is the F stands for? F stands for the frequency. Lambda stands for wavelength. Frequency will remain constant. Okay. So based on this, n number of times they have asked the questions, not only in NEET and also in various state entrance examinations. Okay. So please make a note of this. So first of all, we have to understand what is the absolute refractive index. What is the absolute refractive index? So see here, refractive index is nothing but the ability of a medium to bend the light, okay. Absolute refractive index, usually it can be represented by n, or in some standard books it is also represented as mu, So no need to worry about this symbol, but we have to understand the meaning of the symbol. Refractive index n is equals to c divided by v. What is c here? C is nothing but C is nothing but speed of light. Speed is nothing but the speed of light in air. Speed of light in air or vacuum. Air or a vacuum. Okay. Usually it is equals to 3 into 10 to the power of 8 meter per second. 3 into 10 power 8 meter per second. What is V here? V is the speed of the light in a given medium. Speed of the light in a given medium. In a given medium. Okay. So please make sure about this meanings, okay? And please observe this here. N is equals to C divided by V. See, speed can be written as the product of frequency and wavelength. The product of frequency and wavelength. So from this, it should be very clear that the refractive index of a medium is inversely proportional to speed and is inversely proportional to wavelength of the light used. Is it a, so what is the meaning of this here? What is the meaning of this? We can say that as a speed or as n increases, the speed decreases and the wavelength will also less. As the n is less, if the refractive index of the medium is less, we can say speed will be more and the wavelength will also increase. Is it clear? I hope you are understanding these proportionalities. It's a very, very important thing we have to keep in our mind. Okay. Later we have to understand about what is the relative refractive index. Relative refractive index. So please observe this. If N1 is the refractive index of one medium, and N2 is the refractive index of the second medium, then we can write N21, otherwise N21 like this, or we can write it as N2 divided by N1, that is relative refractive index. So we can call this as a relative refractive index. Therefore, we can say this as N2 by N1 can also be written as V1 by V2, and we can also write as lambda 1 by lambda 2, okay? That is a relative refractive index of the material or the medium or the pair of medium, okay? So please make sure about this. If the refractive index is low, then it is said to be a rarer medium. And the refractive index is high. Then it is said to be denser medium. Okay. So please make sure about these things clearly. If the refractive index is less, then the medium is said to be rarer medium. If the refractive index is high, then it is said to be a denser medium. Okay. Now please observe this. Let us consider a refracting surface xy, which separates the two medium. One is called as a rarer medium and the other one is called as a denser medium. Okay. Let us say this is a normal. Suppose whenever light travels from rarer medium to denser medium, it bends towards the normal. Is it clear? That is the point we have to keep in our mind. So please make sure about these things here. So let I be the angle of incidence and R be the angle of refraction. So say here I is called as angle of incidence. R is called as angle of refraction. Okay. So please make sure about these things here clearly. Suppose if there is no refracting surface, the light would have traveled along the dotted line. Because of the refracting medium, refracting surface, the light would bend. The light will undergo a deviation. It is a delta. Delta is a deviation. And the delta value becomes equals to I minus R. When The light travels from rarer medium to denser medium, rarer medium to denser medium. Okay. And let us see the second case. Let us see the second case. Let us consider xy is the refracting surface which separates the two media. Let us say this is the rarer medium and it is a denser medium. Let us say this is a normal drawn to the surface. Suppose whenever a light ray travels from denser medium to rarer medium, it bends away from the normal. Let I be the angle of incidence, R be the angle of refraction. Suppose there is no refracting medium, suppose there is no refracting surface, xy, then the ray would have traveled on the dotted line, but because of the refracting surface, the light will undergo a deviation. And in this particular situation, deviation is given by R minus I. We have to understand this point clearly. Deviation of the light when it travels from rarer to denser, and also when it travels from denser to rarer. I hope we are understanding each and every point. Later we can move on to the what are the laws of refraction. Okay. So please make sure understanding each and every point. What is the first law? First law states that we can say incident ray, refracted ray, RR, it is not reflected, it is a refracted ray, and the normal lie in a same plane, okay. So please make sure about these things here. And later whenever we move on to the second law, second law is also referred as a Snell's law, we can say that. So please observe this. N1 sine I is equals to N2 sine R here, N2 sine R. N1 sine I is equals to N2 sine R. N1 sine I is equals to N2 sine R. What is N1 and N2 here? Please observe, look at the board here. Let's say N1 is the refractive index of the first medium and N2 is the refractive index of the second medium. If the ray travels from N1 medium to N2 medium, it will bend. Let I be the angle of incidence, R be the angle of refraction. So it depends how the ray is traveling, from where to where the ray is traveling. Either it is traveling from rarer to denser or denser to rarer. According to that, it bends towards the normal or away from the normal. We have to take care of that. So we can say N1 sine I is equals to N2 sine R. Otherwise, we can say that N2 divided by N1 is equals to sine I divided by sine R, okay. And observe this for normal incidence, what do you meaning of normal incidence here? For normal incidence, I is equal to 0 and R is also equal to 0. Therefore, we can say that N2 by N1 becomes equals to 0 by 0. Hence, we can say Snell's law is invalid. For normal incidence. Whenever we consider normal incidence, Snell's law cannot be applied. Cannot be applied. For normal incidence, Snell's law is invalid. Because we are getting 0 by 0. Okay. I hope it is clear to you. That is about the laws of refraction. Okay. Later we have to understand about what is the lateral shift. So please, just I will write the diagram and write the formula. What is the lateral shift? So please observe this. Whenever we consider a slab of thickness T, so please have a look here. Whenever a ray of light is traveling from the air medium, let us say air medium, and n is the refractive index of the glass slab, and again this is the air medium. So please look at the board carefully. What is happening here? Whenever a ray is traveling from air medium to glass medium, it will bend. It will bend towards the normal. Bend towards the normal. Is it clear? So please observe the diagram carefully. And later, when it travels from glass medium to rarer medium, again it bends away from the normal. So whenever you observe this carefully, if there is no glass, the light would have travel along the dotted line. Is it clear? This is the initial direction of the incident light, okay. And if we measure what is the perpendicular distance, between the emerging ray and the direction of the incident ray, then it is called as a lateral shift, okay. Just I am writing here the perpendicular distance between the emerging ray or emergent ray and the direction of incident ray here, and the direction of direction of incident ray, okay, is called as a lateral shift. So what is the expression? For lateral shift? Let's understand this point clearly. Lateral shift can be measured. Using the relation. So please make sure about this here. Lateral shift LS is equals to T divided by cos R into sine of I minus R. Okay. That is the expression for lateral shift. T divided by cos R into sine of I minus R. Okay. That is a lateral shift. Later we have to understand about the next point, that is a normal shift. So please observe this carefully. Let us consider the water medium, because usually normal shift can be observed when there is a water in a beaker or in a tank or in any solid surface, okay. So please observe the diagram carefully. Normal shift I will represent only through diagram here. So let us say O is an object. Whenever a light is incidenting, normally it will go without any deviation, through the point A. But whenever a light is incidenting the surface at some point, what can you say here? It will get refracted, as shown in the figure. But whenever we observe this, the refracting ray, it observes that, or it says that it is coming from the point O dash, Actually, the light is coming from the object O. But whenever we observe the light, whenever we observe the refracting light, it appears to be coming from the object O dash. Okay. Therefore, this we can say that whenever we observe the object normally, it says that object is shifted to the position O dash. Therefore, we can say that AO is called as a real depth. AO is called as a real depth. And what is this here? O dash. Otherwise, AO dash is called as apparent depth. Therefore, we can say O dash is called as, you can say it is normal shift. You can call it as a normal shift. Okay. Therefore, how can you write this normal shift? My normal shift can be written as real depth minus apparent depth. Okay. Therefore, finally, if you simplify everything, we'll get we can say T into 1 minus 1 by n. We can say what is the T here? T stands for real depth of the medium, real depth of the object, real depth of the object. And n is the refractive index of the medium, n is the refractive index of the medium, and t is the real depth of the object, real depth of the object. But it should be very clear, it should be very clear that this is the first case, the first case. What is the first case here? Observe this. I am writing in the bracket. Object is in. Object is in. We can say denser medium. Object is in denser medium and viewed from rarer medium. Viewed from a rarer medium. Viewed from rarer medium. Object is in denser medium and viewed from rarer medium. We can say this is the formula to calculate the normal shift, and we can say refractive index n is equals to real depth divided by apparent depth. N is equals to real depth divided by apparent depth. We can say that is how we can calculate the refractive index of the medium and all those things. Now let us see the second case. What is second case? See here, first case, as I said, object will be in denser medium and viewed from the rarer medium. Is it clear? So observe this. So whenever we move on to the second case, observe this. What is the second case? What is the second case? As I said, the object. Whenever an object is in rarer medium. Whenever object is in rarer medium and viewed from the denser medium, viewed from the denser medium. Okay, for example, a bird is flying in a sky, that is in air medium, and a fish is observing that bird. So fish will become the observer and the bird will be the thing. So denser medium. Is it clear? So in that particular case, we have to understand that refractive index will become equals to apparent depth real divided by real depth. And what can you say about this? Normal shift will become equals to apparent depth minus real depth. Okay, so these are the formulas we have to keep in our mind. In this case, apparent depth will be greater than the real depth. So whenever the object is in rarer medium and the observer is in a denser medium, and in the previous case, real depth will be greater than the apparent depth. We have to keep this point in our mind. Okay, so like that we have to think about the normal shift. Later we can move on to the next concept, that is total internal reflection. Here, what is the total internal reflection? What is the meaning of that here? What are the conditions to get the total internal reflections? We have to think all those things. Okay, so please, what are the conditions? First point, we have to understand that the light should glow from the light should travel from denser medium to rarer medium, and an angle of incidence I should be greater than the C. What is the C here? C is called as a critical angle. So how can we show through the diagram? So please observe this. Let us consider a refracting surface. Let us assume it separates. Let us say it is a water medium. Water is denser compared to air medium. Is it right or not? So let us consider a water medium as a denser medium, and imagine an object which is located in the denser medium. It is a denser medium and this is the rarer medium. The light which is incidenting normally will go without any deviation for I is equal to 0, R is equal to 0. Now let us consider a light which is incidenting at some angle to the refracting surface. Let I be the angle. Then since it is traveling from denser medium to rarer medium, it bends away from the normal. And suppose if we increase the angle of incidence, and it is equals to the C. What is C here? C is the critical angle, the ray will get a graze along the surface such that angle of refraction becomes equals to 90 degree, okay. And similarly, whenever we consider a ray of light which is incidenting at an angle greater than the critical angle, okay, it will undergo the total internal reflection, okay. I is greater than C, I should be greater than C. That is a phenomena of the light coming back to the same medium when it incident at an angle greater than the critical angle. What is the critical angle? The angle of incidence in the denser medium at which the angle of incidence in the denser medium at which the refracted ray grazes the surface, otherwise the angle of refraction becomes equal to 90 degree. Is it clear? So what is the relation? What is the relation here? What is the relation between refractive index and the critical angle? Please remember that critical angle can be defined only for two media or a pair of media, okay. Therefore we can say that n denser divided by n rarer is equals to 1 by sine c, 1 by sine c, okay. In many books they will simply represent n is equals to 1 by sine c by considering the rarer medium as air medium or vacuum, okay. That is the relation between the refractive index and the critical angle. So what are the applications of this here? What are the applications? What are the applications of total internal reflection? Here total internal reflection, just I will mention the names, so please make a note of this. First one, that is the sparkling of diamond. Here sparkling of diamond, sparkling of a diamond, okay. And second point, we can say the formation of the mirages, and third one, that is optical fibers. Fibers is one of the applications of total internal reflection, and later we can go with the total reflecting prisms also. Total reflecting prisms are also based on the phenomena total internal reflection, okay. I hope it is clear to you. That is applications of total internal reflections, and these are the important points, okay. One more concept is there, I will explain that. What is the area? What is the area of a circular patch? What is area of the circular patch? Area of the circular patch of light. Area of a circular patch of light. What is the concept here? Observe this. Let us imagine an object here. Let us imagine an object which is placed in a denser medium, let us say an object O is located at a height or at a depth equal to h, and where the light coming from the object is made to incident at an angle exactly equal to critical angle, the ray will not get refracted into the other medium. It will graze the surface, and we cannot see the light after this particular point, okay. Therefore we can say that there will be a region, or there will be some area through which we can see the object, or we can see the light coming from the object. So how to calculate that area? Let us say r is the radius of the circular patch, h is the depth of the object, which is placed in the denser medium, or especially we'll go with the what is the thing here, that is a thing. So whenever we move on to the simplification, all those things, we will get the radius of the circular patch. Becomes equal to h divided by root of n square minus 1. What is n here? N is the refractive index of the medium, okay. And similarly, what can you say about the area enclosed here? Area, capital A is equals to pi r square. Therefore, A is equals to pi into r square. R square can be as h square divided by n square minus 1. That is the area. That is the area through which the light coming from the object can be seen by an observer. In a rarer medium. Okay, so like that we have to think and we have to analyze these points. And whenever we, for example, if I consider the water as a medium, the refractive index of the water is 4 by 3. Therefore, radius becomes equal to just substitute the value of this here 16 by 9. That means we can go with the 3h by root 7. 3h by root 7. You can use this formula as a shortcut formula. Okay, so these are the points what we have to learn under the concept of refraction at a plane surface. Okay, now let us move on to the next concept, that is refraction. That is refraction through a spherical surface. Here, refraction through a spherical surface. And we have to learn about refraction formula. So let us consider a spherical surface which separates the two media, having the refractive index n1 and the refractive index n2. Okay, let us consider a principal axis and let P be a pole of the spherical surface. So observe this: whenever an object is considered at a distance of u from the pole of a surface, the light which is incidenting on the refracting surface will undergo refraction. It forms the image I, which is at a distance of v from the pole. Okay, so whenever we draw a line through that point to the principal axis, it will meet at a point called as center of curvature. And if capital R is the radius of curvature, then we can write the relation, that is n2 by v minus n1 by u is equals to n2 minus n1 divided by r. And we can call this as a refraction formula. And please make sure about these points here clearly. And this quantity n2 minus n1 by r is there, no? And this particular quantity represents the power of the refracting surface, or the power of the surface. Okay, so like that we have to understand about the refraction formula. Okay, later we can move on to the lens. What is a lens? What is a lens here? Lens is an optical medium. Bounded by two surfaces, of which at least one surface is curved. Okay, that is called as a lens. Lens can be divided into different types. One is called as concave, another one is convex. Another one is the plano-convex lens, and later we can go with the plano-concave lens. Okay, so how can we draw the figure? So concave lens can be represented as shown like this. Concave lens is also referred as a diverging lens. It also referred as a diverging lens. And whenever convex lens can be represented as a converging lens. Okay, so please look at the board carefully. This is the concave lens. What is the plano-convex here? Plano-convex is as shown like this, and plano concave is as shown in the figure. Plano convex, usually observe this, concave lens is presented as, or it is called as a diverging lens, and convex lens is represented as a, what is it, converging lens. So please make sure about these one things my here. And later we have to consider, whenever we consider a convex lens, there will be an optic center here. There will optic center. What is the meaning of this optic center? Optic center indicates that whenever a light which is incidenting, and which is passing through the optic center will go without any deviation. What is optic center? I am repeating, the point inside the lens through which the light will go without any deviation is called as a optic center. What is the O? O is called as a optic center. Okay. So please make sure about these things here clearly. Now let us move on to the what is the lens formula? Okay. So what is the lens formula here? It is nothing but the relation between the focal length, object distance, and image distance is called as lens formula. That is 1 by f is equals to 1 by v minus 1 by u. 1 by f is equals to 1 by v minus 1 by u. Okay. And later we have to think about what is a lens maker's formula. Okay. So please follow these things without a lens maker's formula. It is 1 by f is equals to refractive index of the lens divided by refractive index of the surroundings minus 1 into 1 by r1 minus 1 by r2. We have to understand this carefully. So what is NL here? NL is the refractive index of the lens material. NS is the refractive index of surrounding medium. Okay. R1 and R2 here. R1 and R2 are radii of curvature. R1 and R2 are the radii of curvature of both the surfaces. Is it clear? I hope you understood these points clearly. Now let us understand about the cases. First one, we can say that if the refractive index of the lens medium is greater than the refractive index of the surround medium, then the lens will behave as our lens exhibits its original nature. We can say lens will exhibit or will exhibit its original nature. Okay. So please make sure about these things here clearly. So if NL is greater than NS, lens will exhibit its original nature. And second case, what is the original nature? Suppose if I consider the convex lens in any other medium, convex lens will always converge the light. That is, it shows the converging behavior. Suppose if I consider the concave lens, usually the original nature of the concave lens is diverging. Therefore, whenever we take the concave lens in any medium which is having the lower refractive index, then it behaves as a diverging lens. Similarly, if n lens is less than the n surroundings, that is surrounding medium refractive index is greater than the refractive index of the lens, then we can say lens will change its nature. That is, convex will behave like a concave. Convex lens will behave like a concave lens, and concave lens will behave like a convex lens. Okay. And third case, whenever we want third case, we can say that if NL is equal to NS, if NL is equals to NS, then lens behaves like a glass plate or a transparent plate. Lens behave like a transparent plate. Okay, so like that we have to think about the different cases. Is it clear? So based on this they can ask the question, they can ask the questions without fail. Okay, later we can move on to the next concept. What is the next concept we can say here? So please, that is the power of the lens, power of a lens. Power of a lens. How can we define the power of the lens here? We can say the ability of a lens to converge the incident light or to divert the incident light is the power of a lens. So observe this. Power P is equals to 1 by F. 1 by F. The unit of the power is diopter. Unit of the power is diopter, we can say. Diopter denoted by capital letter D. And here we have to use this formula when focal length is in meter. When the focal length is in meter, or we can say power is equals to 100 by F diopters. 100 by F diopters when focal length is in centimeter. When the focal length is in centimeter. Okay, if the focal length of the lens is measured in centimeter, then the formula to measure the power is 100 by F. 100 by F. Okay, and when the focal length is in meter, then the power of the lens is measured as 1 by F. 1 by F. Okay, so these are the things what we have to keep in our mind without fail. Okay, later we can move on to the next concept, that is cutting of a lens. Cutting of a lens. Please make sure you are understanding these points clearly. Whenever we consider a convex lens as shown, case 1 I am discussing, and whenever we cut the lens, along the principal axis, then we will get the two pieces here. Then we get the two parts. Then we can say what is the focal length of the each part. It is equals to F. What is the F here? F is the focal length. F is the focal length of the original lens. F is the focal length of original lens. F is the focal length of original lens. So after cutting, the focal length of each part will also become equal to the focal length of the original length. And whenever we move on to the second case, let us consider this is the initial lens. We have to think. And whenever the lens is cut, okay, perpendicular to the principal axis, then we will get the two parts as shown in the figure. Okay, so please make a note of this. Then what is the focal length of each part here? Focal length of each part becomes equals to 2 times the focal length of the original lens. Is it clear? I hope you're understanding these points. Now let us move on to the next one. We have to understand that whenever the lens is made up of different materials as shown in figure. Whenever the lens is made up of different materials. So please observe this and note down each and every point. Then observe the things here. Sorry. Whenever we consider the lens, which is made up of n different materials here. Suppose see here n. Okay, please, I will show the diagram and later I will explain to you. So observe this. Whenever we imagine an object, the light coming from the object is made to incident on all the parts of the lens, on all the parts of the lens. Okay, and each part will form the image at different locations, at different locations. Okay, therefore whenever we calculate the total number of images, okay, I'll write in the sentences. If a lens is made up of a lens is made of n different materials, n different materials in different materials then we will get n number of images, n number of images. Is it clear? So like that we have to think. This is the image 1, image 2, image 3, image 4, image 5. In this example, the lens is made up of 5 different materials. Therefore, the lens will form or will give you 5 different images for a single object. Is it clear? So that is about the cutting of a lens and how the lens is made up of n different materials. Okay, later we can move on to the combination of the lens. Later we can move on to the combination of the combination of a lens. So please observe this. Whenever we consider two thin lenses, which are placed in contact, let f1 and f2 are the focal length of the two thin lenses. Then we can write 1 by f equivalent is equals to 1 by f1 plus 1 by f2, 1 by f1 plus 1 by f2. Is it clear? That is a effective focal length, or if you simplify this, f equivalent is equals to f1 f2 divided by f1 plus f2, f2. And please remember the sign convention here. What is the sign convention? So please make a note of this. For convex lens, for convex lens, first of all I am defining. We should be very careful with the convex lens, because convex lens will form both real images as well as virtual images, similar to that of concave mirror. Okay, therefore we can say for convex lens, we can say focal length is taken as plus f. And please look at the board carefully. And object distance is always negative, either for convex lens or for concave lens. Okay, later we can say what is the magnification formula. Magnification is equals to m, and for convex lens it is equals to plus m for virtual images, and m is equals to minus m, that is a negative for real images, and please make sure magnification is equals to hi, height of the image divided by height of the object, otherwise size of the image divided by size of the object, or in terms of object distance and image distance we can say v by u. Is it clear? That is a magnification formula. Many people will get confused between the mirror and the lens. For the mirror, magnification is minus mv by u, and for lens magnification is plus v by u. So don't get confused, okay. And similarly for concave lens, we can say focal length is minus f. Object distance is equals to minus u, and magnification m is equals to minus, not minus, it is a plus m, because concave lens always form The virtual images always forms virtual images, images. Is it clear? But convex lens will form both virtual images as well as real images. That we have to remember clearly. Is it clear? So like that we have to understand and we have to apply the sign convention. And one more thing, what is the power? Power is equals to plus P. Power of the convex lens is positive and power of the concave lens is taken as minus P, P. Okay. So based on this, we can write what is effective power here. Effective power. Please observe this. Equivalent power is equals to P1 plus P2. Equivalent power is equals to P1 plus P2. Now let us see. Let us understand about if the two lenses, if the two lenses are placed or separated at some distance, two lenses are separated by some distance, if D is the separation between the two thin lenses, then we can write 1 by F equivalent is equals to 1 by F1 plus 1 by F2 minus D divided by F1 into F2, F1 into F2. Therefore, we can say equivalent power is equals to P1 plus P2 minus D into P1 P2 minus D into P1 P2. Like this, we have to write the equivalent focal length and equivalent power, equivalent focal length and equivalent power. Okay. I hope you are understanding clearly and writing each and every point, and I requesting everyone to practice as many times as possible before going to solve the numerical problems. Okay. Yes, that is about the combination of the lens. Now let us move on to the next point. What is the next point? We can say here it is displacement method. This is one of the displacement method to find the focal length of the lens. This is purely a practical based concept. So let us consider O is an object. And let us imagine we have considered the lens. Is a lens stand. This is a lens stand over which we are placing a lens. Let us say L1 is the first position. L1 is the first position of the lens. And observe this. This is a screen. And whenever a light is considered from the object, and whenever it is made to incident on the lens, it forms the image. Let us say I1 is the image of the object. When the lens is at the first position. Is it clear? And capital D is the distance between the object and the screen. Okay. So please make sure. And if the lens is moved, moved from the position L1 to L2, let us say L2 is the second position and S is the displacement here. S is the shift of the lens. Capital D is the distance between the object and the screen. Then we can say focal length F is equals to D square minus S square divided by 4D. D square minus S square divided by 4D. It is measured in unit or centimeter, whatever it may. Generally, focal length is measured in terms of centimeters only. That is a displacement method to calculate the focal length of the lens. So please observe this. Look at the board. When the lens is in the second position, the light which is incidenting on the lens, will form the image. Let us say I2 is the size of the image. Let I1 and I2. I1 and I2 are the size of the image when the lens is at L1 and L2 positions. L1 L2 position, then we can say size of the object. Size of the object O is always equals to root of I1 into I2. Root of I1 into I2. Is it clear? So please observe this. M1. What is M1 here? M1 is the magnification here. Magnification at the L1 position of the lens. L1 position of the lens. M2 is the magnification at the position L2. At the position L2. Then we can write the product M1 into M2 is always equal to 1. These are the questions which can be expected. So based on practicals. Okay. This is the displacement method to calculate the focal length of the lens. So based on this, we can expect the questions in the NEET entrance examinations. Okay. Now let us move on to the next concept. That is prism. Next topic, not concept. That is prism. So what are the important formulas we have to learn under the concept of a prism? Please consider what is a prism. Prism is nothing but an optical medium. Bounded by. We can say two triangular faces and one rectangle. Two triangular faces and three rectangular faces. Okay. But anyway, whenever we consider the prism, please make sure about these things here. This is the base of a prism. ABC is a prism. Capital A is the angle of prism, or we can also say it as a prism angle. Capital A is the prism angle. And whenever a light is made to incident on the prism at an angle, let us say I1, it undergoes a refraction. Let us say this is P, Q, R and S. S is the emergent ray. I1 and R1 is angle of refraction at the first phase. R2 is angle of incidence at the second phase. I2 is angle of emergence or angle of refraction at the second phase. Okay. Therefore, from this it should be very clear. We have to write the important points. What are they? First one, please observe this. Angle of prism is equals to R1 plus R2. Prism angle is equals to R1 plus R2. Suppose if there is no prism, the light would have traveled along the dotted line. Is it clear? Therefore, there will be some deviation in the light, delta. So observe this. Deviation delta becomes equals to, we can write or we can show I1 plus I2 minus of R1 plus R2, or we can write delta is equals to I1 plus I2 minus capital A. And one more thing, it should be very clear. If n is the refractive index of the prism, then we can write n can be written as sin I1 by sin R1, it is equals to sin I2 divided by sin R2. Sin I2 divided by sin R2. That is the refractive index of the material prism. Okay. And at deviation is equals to minimum deviation here. A deviation is equals to minimum deviation. Then we can say that capital A is equals to 2R. We have to remember these important results here. R becomes equals to A by 2 and angle of incidence is equals to A plus D by 2. Therefore, n becomes equals to sin of A plus D by 2 divided by sin A by 2. Okay, there is a prism formula. And one more thing, at delta, deviation is equals to minimum deviation. the refracted ray, the refracted ray inside the prism, refracted ray inside the prism, prism, inside the prism will be parallel to the base of a prism, will be parallel to the base of a prism, will be parallel to the base of a prism. This is very very important, because sometimes they will not mention directly the prism is in minimum deviation position, but they will give in sentence, that is the refracted ray inside the prism is parallel to the base of a prism, which indicates the prism is in minimum deviation position, position. Okay, so please make sure about these things here. And later, what is a thin prism? What is a thin prism? Okay, please have a look here. Thin prism deviation. What is the thin prism? The prism whose angle of prism, or whose refracting angle or prism angle is less than 10 degree, and the deviation is equals to n minus 1 into capital A. From this, it should be very clear that deviation is directly proportional to refractive index, and refractive index is inversely proportional to critical angle, and it is inversely proportional to the speed of the light, and is inversely proportional to the wavelength of the light, So to answer some theoretical based questions, we have to learn these proportionalities without a fail. Okay, now have a look here. Whenever a white light is made to incident on the prism, what is the white light? White light is nothing but the composite light. Is it clear? Therefore, please observe this. This is the red color, and this is the, let us assume this is a violet color. Okay, so therefore, please have a look here. The red color deviates least, and violet color deviates most, we can say. In between violet and the red, we can observe the different colors, mother, we can call it as vibgaya, and this is called as a spectrum. We call it as a spectrum, and this phenomenon is called as dispersion of the light. The dispersion is nothing but the splitting of white light into its constituent colors, is called as a dispersion. Therefore, please observe this. We can say that the wavelength of the red is greater than the wavelength of the violet. We can say that deviation of the red will be less than the deviation of the violet. Is it clear? So like that, we have to think and you have to answer the which color will be deviated most and which color will be deviated the least. Is it clear? I hope you understood these points clear. That is a dispersion, concept of dispersion, the splitting of white light into its constituent colors, Is it clear? I hope you understood. These are the points what we have to learn under the concept of a prism. Okay. Now let us move on to the last concept of this particular chapter, that is optical instruments. Optical instruments. What are these optical instruments here? Optical instruments are nothing but the devices which are used to observe the objects, which cannot be seen with our naked eye. So observe this. Art is a combination, the instruments which consists of the combination of lens, mirrors and prism. Okay, there is optical instruments. Among them, the first one we can say it is a simple microscope. First one, it is a simple microscope. Okay, so please have a look here. What is simple microscope? It consists of only one lens. Simple microscope consists of only only one lens, and we can also call it as it is also called as a converging lens. Simple microscope is also called as a converging lens. Okay, and later, what is the principle? What is the principle? Principle behind this working of simple microscope, that is the object is placed, object is placed between the principal focus and the optic center, optic center. Then then observe this: when object is placed between the principal focus and the what is the optic center, then we can get the magnified image. We can get a magnified image. We can get the magnified image. Therefore, what is the magnification? M is equals to 1 plus d by f. 1 plus d by f when the image is formed, formed when the image is formed at capital D usually it is equals to taken as 25 centimeter here. What is capital D? Capital D is nothing but least distance of distinct vision. Least distance of distinct vision. Is it clear? I hope you're understanding each and every point. And M is equals to capital D divided by F. Capital D by F when the image is at infinity. When the image is formed at infinity, we can write M is equals to D by F. That is the magnification formula in case of a simple microscope. Okay. Later we have to understand what is capital D. Capital D is nothing but the least distance of distinct vision. For a normal eye, which is not having any defect, that is the minimum distance at which a normal eye can see the object clearly. That is called as least distance of distinct vision, and usually its value is equals to 25 centimeters. Is it clear? I hope you are writing each and every point. Later we can move on to the next one. That is a compound microscope here. Next one we can say it is a compound microscope. So please have a look here. Compound microscope, it consists of two lens. FO is less than FE. The focal length of the objective is less than the focal length of the eyepiece. Okay, and later we can say that magnification is always equals to the product of magnification produced by the objective and magnification produced by eyepiece. Okay, so please have a look here. The intermediate image formed is real, inverted and enlarged. What is intermediate image? See here, whenever an object is placed near the objective of the compound microscope. Okay, object is the compound microscope. It forms the objective first. It forms the image in front of the eyepiece. That is called as an intermediate image. Okay, and later we can say that what is the magnification? Magnification is equals to VO divided by UO into 1 plus D divided by FE. So when we can use this formula here? When the final image is formed at capital D, D. Okay, and later please observe this: M is equals to VO by UO into D by FE, D by FE. That is the magnification. This is when when the image is formed, when the image is formed, when the image is formed at infinity, when the image is formed at infinity. Is it clear? So that is about the magnification formula related to compound microscope. Compound microscope. Okay. I hope you understood this point clearly. And in order to calculate the image distance or object distance or focal length or objective or focal length of the eyepiece, we can apply lens formula. What is the lens formula? 1 by f is equals to 1 by v minus 1 by u. So whenever we apply that lens formula, happily we can what is the find whatever the quantities we require. Okay, that is about the things we have to understand in case of compound microscope. Okay, so finally, anyway, please have a look here. What is the final image, final image is virtual, comma, is virtual. Okay, enlarged is virtual, enlarged and inverted with respect to objective, object in compound microscope. Whenever you observe the final image in compound microscope, it is inverted, enlarged, but it is virtual. It is virtual because we cannot cut on the screen. We cannot catch that image on the screen. Finally, we can move on to the astronomical telescope. Here, astronomical telescope. What is the telescope here? Telescope is an instrument, which is used to see, very far objects. Is it clear? And here also we can say there will be two lens. There will be two lens, and here we can say, so focal length of the objective will be greater than the focal length of the eyepiece. It is exactly opposite to compound microscope. So observe this. When okay, here I have missed one more point. What is the length of the tube or length of the compound microscope? L is equals to VO plus UV. That is the object with the image distance with respect to objective plus object distance with respect to eyepiece. Okay. So please, when the image, we usually study about when the image is formed. The image is formed at infinity. When the image is formed at infinity, we can say that magnification is equals to minus FO by FE. And what is the length of the tube? Is FO plus FE. Here, what is L? L is the length of the tube. Tube is nothing but a telescope. Okay, I hope it is clear to you. So like that, we have to think and we have to understand about the things. Suppose when the image is formed at the least distance of distinct vision, then the magnification is equals to FO by FE into 1 plus FE divided by capital D. But to the maximum extent, the questions will be asked from these two relations, with respect to telescope. Okay, so these are the points what we have to learn, from the telescope. And finally we can go with the Cassegrain telescope. Here, Cassegrain telescope. This Cassegrain telescope which consists of the primary mirror. Is it clear? Primary mirror. So please observe this. Cassegrain telescope consists of, please have a look here. Cassegrain telescope is as shown like this, is as shown like this. Please have a look here. Any confusion you can ask. Any confusion you can ask. So opposite to this is the primary mirror, which is nothing but a concave mirror, and exactly opposite to this there will be a secondary mirror. This is a secondary mirror. This is a secondary mirror. Whenever a light is made to incident on the primary mirror, so please have a look here. It gets reflected back through the lens, it get reflected back through the lens. There will be an objective lens, we can say. So see here, Cassegrain telescope consists of mirrors, okay, instead of a lens, so that the brightness and the intensity of the image will be high compared to astronomical telescope. Is it clear? I hope you understood each and every point. These are all the concepts. These are all the concepts, or these are all the formulas, or these are all the important points. What we have to keep in our mind. What we have to keep in our mind to solve the MCQs or the numericals from this particular chapter, ray optics and optical instruments. Okay. I hope you understood these points clearly, without any confusion. Okay. So please go through that once, and please refer before going to solve the numericals. Okay. So please, I hope you will do it, and you practice these formulas as many times as possible. Okay. Now let us see the first question. What they have given, in the what I have considered, and these are all the questions which are asked in previous years NEET papers also. Please read this question, what they are saying to us. A lens is made up of three different transparent media as shown in the figure. A point object O is placed on its axis beyond 2f. How many real images will be obtained on the other side? As we discussed just now in the previous discussion of the concept. See here, if there are three materials, if the three lens are made of three materials, three materials. Okay, therefore we can say that the number of images will also be equals to 3, which is equal to 3. Is it clear? If the lens is made up of n number of materials, then the number of images will also be equal to n. Okay. Hence we can select option D as the right answer. Here option D is the right answer. So move on to the next one. What they are saying to us. Please read this question carefully. So observe this. If epsilon naught and mu naught are the electric permittivity and magnetic permeability of the free space respectively. If the corresponding quantities of a medium are 2 epsilon naught and 1.5 mu naught respectively, the refractive index of the medium will nearly. They are asking what is the refractive index of the medium. So we know that. Let's see here. We know the refractive index is equals to C by V. Okay, what is the C value? We can say it is equals to 1 by root of mu naught into epsilon naught, 1 divided by 1 by, what is V value? V value is 1 by root of mu into epsilon. Okay. So just substitute the values and just simplify this, then definitely you will get the answer. So just do simplification here. We can write this as root of, it is equals to root of mu into epsilon divided by mu naught into epsilon naught. So n is equals to what is the mu value? Mu value is equals to 1.5 mu naught into epsilon value is 2 epsilon naught divided by, we can say mu naught into epsilon naught, mu naught into epsilon naught. Okay, mu naught, epsilon will get cancelled. We can say it is 2 into 1.5. Therefore, refractive index is equals to root 3. It is equals to root 3. Hence, we can select option B as a right answer. Option B is the right answer. Okay, I hope you understood this question clearly. So move on to the next one. What they are saying to us: a horizontal ray of light is incident on a right angled prism with prism angle of 6 degree. What is the angle of prism? They have given 6 degree. Is it clear? And observe this: a horizontal ray in the sense we can say for a horizontal ray, we can say I1 is equals to R1 is equals to 0. Okay. So observe this. What is the refractive index of the material of the prism? It is 1.5. Then they are asking what is the angle of emergence? What is the angle of emergence? Okay. So how can we do simplification here? Observe this. We know that angle of prism is equals to R1 plus R2. Therefore, A is nothing but 6 degree, R1 is 0 plus R2. Therefore, we can say that R2 becomes equals to 6 degree. R2 is equals to 6 degree. Okay. Therefore, substitute the value of this in this equation here. N is equals to sine I2 divided by sine R2. What is N value here? N value is equals to 1.5, which is nothing but sine I2 divided by sine 6 degree. Okay, therefore just do simplification here. Sine I2 is equals to 1.5 into sine 6 degree. So whenever we do simplification, then you will get 1.5 into 6 degree. Since angle is very small over here, since theta is very small, we can approximate I2 is approximately equals to 1.5 into 6. Therefore you will get nearly 9 degree. We will get it. So when angle of prism is small, or when R2 is small, I2 is also small, we can go with option A as a right answer. Option is right answer. Okay, I hope it is clear to you. Now let us move on to the next question. Please read this question here. Which set of colors will come out in air for a situation shown in figure? So whenever observe the diagram carefully here, white light is incidenting from the glass to the air medium. Okay, observe this. The green light is undergoing the green light is grazing the surface. White light is a composite light which consists of all the colors Vib-Gayar, including all those things. So please observe this. Please analyze this question here. So green light is grazing. Grazing. Okay. So we know that refractive index is inversely, that is 1 by sine C here, and it is proportional to 1 by lambda. Okay, therefore we can say that critical angle is directly proportional to wavelength. Suppose if the wavelength is more, critical angle will also be more. Therefore we can say that for whenever the wavelength is more, the critical angle will also be more. That is, therefore, for a given angle of incidence, since we can say that among all the things, we can go with. So beyond green, we can have that lambda green, yellow, and we can say that lambda orange and lambda R high. The critical angle for these rays for these colors will also be more. Therefore, these colors will come out of the thing. Hence, we can select option A as a right answer. Option A is the right answer. If the wavelength is more, the critical angle will also be more. Okay. So based on that, these three colors will emerge out of this glass slab. Will emerge out of this glass slab. Okay. So now move on to the next question. Move on to the next question. What they are saying to us. Please observe this. An object is mounted on a wall. An object is mounted on a wall. Its image of equal size is to be obtained on a parallel equal size. That means height of the image is equals to height of the object. Therefore, magnification is equals to 1. So therefore, whenever we observe the magnification is equals to 1, we can say image distance must be equal to object distance. That is a point we have to keep in our mind. Is it clear? So please observe this. With the help of a convex lens placed between these two walls, the lens is kept at a distance x, in front of the second wall, So let us say this is the first wall, and this is a second wall. In between. First of all, see here, to get, see here, observe this. This is the object, and to get a clear image, the distance between the object and the screen must be equals to 4f. The distance between the object and the screen must be equal to 4f. That is the condition to get a clear image of an object. So whenever a lens is placed, we can say same size image is obtained. That means the lens is placed at a distance of x from the second wall. And from this equation, or from this knowledge, we can say that x must be equals to 2f. This x must be equals to 2f. That means from here to here it must be equals to 2f, and here to here it must be equals to 2f. Therefore, what is the focal length? Focal length will become equals to x by 2. Hence, we can select option C as a right answer. Here, option C is the right answer. Okay. I hope you understood this question clearly. Now move on to the next question. What they are saying to us. Please read this question. Light travels a distance x in time t1 in air, and 10x in time t2. Here they are saying in time t2 in another denser medium. What is the critical angle for this medium? How can we do this? Observe this. In air, what is the speed? Speed is usually represented as c. Speed is equals to distance by time, x by t1. Okay, let's keep that value as it is. Okay, now observe this. In any medium, speed is equals to v. Is equal, what is the distance traveled here? 10x divided by time t2. Therefore, what is the refractive index? We can say here, refractive index. They're asking what is the critical angle? First of all, calculate what is the refractive index. That is n2 divided by n1, which is equals to c by v. What is c here? X divided by t1, and here we can say here 10x divided by t2. Is it clear? What is the c by v? We can calculate here. Calculate. Okay. So calculate this value here. We can go with this as t2 divided by 10 t1. But what is n2 by n1 here? N2 by n1 is equals to 1 by sine c. Therefore, sine c is equals to n1 by n2, which is nothing but 10 T1 divided by T2. Therefore, C is equals to sine inverse of 10 T1 divided by T2. 10 T1 divided by T2. Hence, we can select option C as the right answer. Option C as the right answer. Okay. I hope it is clear to you. So like that, we have to think and we have to answer the given questions. Now move on to the next one. Move on to the next question. What they are saying to us. I hope it is clear. These are all the questions which are asked in previous years NEET papers. So think about the next one. What they are saying to us. Please read this question carefully, ma, here. In the figure shown here, what is the equivalent focal length of the combination of the lenses So whenever we observe this, please look at the board, and we can split this into three lenses. One is plano concave, and the other one is convex lens, and the other one is again, this is the thing. Let us say this is f1, this is f2, and this is f3. R1 is equals to R2 is equals to 20 centimeter. They are saying here. So think about this. Here R1 is equals to infinity, and for this R2 is equals to 20 centimeter. And here also it is for second lens. For a second lens, it is 20 centimeters, and this is also 20 centimeter. And for third one, this is 20 centimeters, and this is infinity. This is infinity. Okay. So now, what is effective focal length here? 1 by f equivalent is equals to 1 by f1 plus 1 by f2 plus 1 by f3. 1 by f3. Is it clear? I hope you are understanding these points clearly. Therefore, first calculate what is 1 by f1. What is 1 by f1? And use the relation. That is, okay, I will write the formula first of all. 1 by f is equals to n minus 1 into 1 by r1 minus 1 by r2. Is it clear? So like that, we can use this formula to calculate the individual focal length. That is 1 by f1. 1 by f1 is equals to what is n1 value here? Okay. And this n2 they are saying, let us say 1.6 minus 1 into 1 by r1 is infinity minus 1 by r2. R2 is equals to 20 centimeter. R2 is equals to 20 centimeter. So whenever we do simplification, then you will get the answer as minus 3 divided by 200 something. You will get it here, minus 3 divided by sorry, you will get the answer as approximately what is the answer here? 0.6 divided by 20 means we can say minus 3 divided by 100. Minus 3 divided by 100. That is 1 by f1 value. 1 by f1 value. And similarly, what is 1 by f2 value? We can say 1 by f2 is equals to, we can say second lens, no, f2. Okay, 1.5 minus 1, 1.5 minus 1 into 1 by 20. 1 by 20. Okay, this is a convex lens, no, here minus 1 by infinity. So whenever, sorry, I will rewrite this. I am going to calculate the focal length of this convex lens, equiconvex lens. Therefore, you can say 1 by 20 minus of 1 by minus 20. We will get it here. So whenever we do simplification, then you will get the answer as approximately 1 by 20. 1 by 20. If you want, we can check it. If you want, you can check it. Then you will get the answer as 1 by 20. 1 by 20. Okay. And similarly, 1 by f3. 1 by f3. So therefore, 1 by f3 becomes equals to, we can say 1.6 minus 1 here. 1.6 minus 1 into 1 by minus 20 minus 1 by infinity. Therefore, whenever we do simplification here, 1 by f3 is equals to 0.6 into, okay, minus 1 by 20. Whenever we do simplification here, again you will get minus 3 by 100. Therefore, equation 1, let us say this is equation 1 here. Equation 1 implies 1 by f equivalent is equals to 1 by f1 plus 1 by f2 plus 1 by f3. So just do substitution and simplification, then you will get the answer as minus 1 by 100, minus 1 by 100. Okay, so like that we have to think and we have to answer this question, and finally you will get F equivalent. F equivalent becomes equals to minus 100 centimeter. Therefore, what is the option we can say here? We can select option B as the right answer. I hope you can understand and you can solve the simple calculations at this end. So similarly, move on to the next question, what they are saying to us. Please observe this. Two thin lenses of focal length F, but one is convex and the other one is concave. Let us say F1 is equals to plus F and F2 is equals to, okay. Actually, this must be small f, this must be small f. So, is equals to minus f, because convex lens will have the positive focal length, concave lens will have the negative focal length. When they are placed in contact with each other, the equivalent focal length of the combination will be, therefore, in contact, 1 by f equivalent is equals to 1 by f1 plus 1 by f2. So, please do the simplification here. 1 by f minus 1 by f, it is equal to 0. Therefore, F equivalent is equals to 1 by 0. 1 by 0 indicate we can say it is infinity. We can say it is infinity. Okay. I hope you understood this option C as the right answer. Option C is the right answer. Now, similarly, see, observe this. These are all the questions which are repeatedly asked in the NEET as well as in various state entrance examinations. So, observe the thing and answer this question. An astronomical refracting telescope is being used by an observer to observe planets in normal adjustment mode. What is normal adjustment mode? Normal adjustment mode is nothing but the final image. The final image is formed at infinity. Formed at infinity. Okay. So observe this. The focal length of the objective and the eyepiece used in the construction of the telescope is, objective focal length is 20 meter and the eyepiece focal length is 2 centimeter. They have given so 2 centimeter, 20 centimeter and 2 centimeter. Is it clear? So please calculate what they're saying to us. Consider the following statements about the telescope. Okay. So please observe this. So whenever we consider this focal length of the objective 20 meter is nothing but 2000 centimeter. We should be very careful in the units. Now observe this. The distance between the objective and the eyepiece is, the distance between the objective and the eyepiece is 20.02 meter. They have given. Okay, first calculate what is the distance. First one, L is equals to just FO plus FE. Is it clear? What is the FO value here? We can say 2000 plus FE is 20. That is the thing. But 2020 meter, which is nothing but 20 point. Is it clear? 20.02 meter. I am getting my here. Okay, 2 centimeter. No. We can say 2002, that means 20.02 meter will get. That is sentence or the statement A is correct. Statement A is correct. The magnification of the telescope is minus 1000. They have given my here. Okay, please check it my here. Second one, magnification is equals to minus FO divided by FE. Minus FO is 2000, FE is 2. Therefore, magnification is equals to minus 1000. Hence, we can select sentence B or the statement B also as a right one. So, image of the planet is erected. It is wrong. It is inverted. So telescope always forms inverted images. Therefore, we can say the statement C is wrong. The aperture of eyepiece is smaller than that of objective. We know that objective focal length is greater than the eyepiece focal length. Therefore, aperture of the eyepiece is smaller. Hence, we can say the sentence D is also the correct one. So, We can go with A, B and D. A, B and D. That is option A as a right answer. Option A is the right answer. Okay. Now similarly, move on to the next one. What they are saying to us. Please read this question here. A biconvex lens has radii of curvature 20 centimeter each. If the refractive index of the material of the lens is 1.5, then the power of the lens is. Please take this problem as a homework. Please take this problem as a homework. Okay. So they're asking what is the power. Power is nothing but 1 by F equivalent, 1 by F equivalent. Okay. So please calculate this properly. Use the relation n minus 1 into 1 by R1 minus 1 by R2, and please take care. If we get focal length in centimeter, then use the power formula. Okay, first of all, you carry 1 by F equivalent here. Then the power is equals to 100 divided by F equivalent. Equivalent, because we will get F equivalent in centimeters. As what is R1 here? R1 is equals to plus 20 centimeter, and R2 is equals to minus 20 centimeter. Therefore, whenever we do substitution and whenever we do calculation here, then you should get the answer as option C, that is 5 diopters. Okay. Yes, let us see the next one. Let us see the next question. What they are saying to us. Please read this problem carefully. A light ray falls on a glass surface of refractive index root 3 at an angle 60 degree. The angle between the refracted and reflected rays would be, what is the angle between the refracted and the reflected rays? So please observe this. The angle between the refracted and reflected here. So refractive index is given to you. N is equals to root 3. N is equals to root 3. Okay. So at an angle 60 degree. Therefore, angle of incidence is equals to 60 degree. So please check it here. N is equals to root 3. Okay. And this is the problem which is based on what is it? Wave optics concept. That is what is the Brewster's law, based on Brewster's law. Therefore, see here, we know that n is equals to tan theta p, which implies root 3 is equals to tan theta p. Therefore, theta p is equals to, we can say it is 60 degree. That means the angle of incidence is equals to polarizing angle. Angle of incidence is equals to polarizing angle. Okay. At polarizing angle at I is equals to theta p, that is at angle of incidence equals to polarizing angle. We can say directly the reflected and refracted rays, are perpendicular. Okay. Therefore, we can say option C as the right answer. Okay. I hope you are understanding these questions more clearly. So option C will be the right answer. Option C is the right answer. So move on to the next one. Move on to the next question. What they have given to us. When light propagates through a material medium of refractive relative permittivity epsilon r and relative permittivity mu r, the rest of the light V is given by, we know that the speed of the light in any medium is equals to 1 by root of mu into epsilon. 1 by root of mu can be written as mu naught into mu r. Epsilon can be written as epsilon naught into epsilon r. So we can write this value as 1 by root of epsilon naught into mu naught, epsilon r into mu r. So whenever we do simplification, V is equals to C divided by, we can say mu r into epsilon r. Okay. Hence we can select option D as a right answer. Here option D is the right answer. I hope it is clear to you, students. Now, similarly, move on to the next one. Move on to the next question. Two transparent media A and B are separated by a plane boundary. Separated by a plane boundary. Let us say there is a boundary. Let us say this is a media A and this is a media B. The speed of light in those media are, what is speed of the light in the media A here? 1.5 into 10 to the power of 8 meter per second, and the speed of the light in the media B is 2 into 10 to the power of 8 meter per second. To in respect the critical angle for a ray of light for these two media, they are asking what is the critical angle. There, first of all, calculate what is the refractive index of the media, that is C by VA. C is 3 into 10 to the power of 8 divided by VA is 1.5 into 10 to the power of 8, which is nothing but 2. So what is the refractive index of the media beam here? So 3 into 10 to the power of 8 divided by 2 into 10 to the power of 8 will get it. So whenever we do this, we are getting the answer as 1.5. Okay. So therefore, better you will change the medium here. So we can say that the light is A to B. Critical angle. When they are asking us to calculate the critical angle, we must have the basic knowledge that the critical angle can be calculated when the ray travels from denser medium to rarer medium. Therefore, A will be the denser medium and B will be the rarer medium based on the refractive indices. Okay. So please observe this. Please observe this carefully. Whenever a ray of light is made to incident, here we can say NA into sin C is equals to NA into sin C. NA into sin C is equals to equal to NB into sin 90 degree, because at critical angle the angle of refraction must be equals to 90 degree. It must be equals to 90 degree. Okay, so just do simplification here. We can say 2 into sin C is equals to, what is NB value here? 1.5 into 1. So whenever we do simplification, sin C is equals to 1.5 divided by 2. 1.5 divided by 2, you get 0.75, you will get it. Therefore, I am writing here, observe this, sin C is equals to 0.75, or sin C is equals to sin inverse of 0.75. Sin inverse of 0.75. Hence, we can select option B as the right answer. Option B is the right answer. Is it clear? C becomes equals to sin inverse of 0.75. So similarly, move on to the next question. What they are saying to us. An object is placed on the principal axis of a concave mirror. So whenever we are solving the problems based on mirrors or the lens, first we have to concentrate. What is the nature of the mirror given to us? Concave mirror at a distance of 1.5 f, where f is the focal length. The image will be at. Okay, I hope you can do this question here. For concave mirror, we can say object distance is always negative. That is 1.5 f. So they are asking what is v. V? So observe this concave mirror. Focal length is also negative. Therefore, use the relation 1 by f is equals to 1 by v plus 1 by u. That is a mirror formula. And please simplify. So please take this problem as a homework. So substitute all the values with the sign convention. Then the v you will get directly in sign convention, and it must be equals to option A as the right answer. Okay, I hope you can do this. Do this. So move on to the next question. What they are saying to us. So please observe this. An object is placed at a distance of 40 centimeter, okay, from a concave mirror of focal length 15 centimeter. 15 centimeter. What is the mirror given to you? Concave mirror. We have to concentrate on the mirror. So observe this. That is the first case, okay. If the object is displaced through a distance of 20 centimeter towards the mirror, the displacement of the image will be, okay. So I will explain how to do this, and I am giving this problem as a homework, and we have to solve this problem. Problem, okay. So please observe this first case. What is the first case? Here, case 1. So look at the board carefully. This is the lens. Initially, the object is at a distance of, what is the distance of the object? Here 40 centimeter. Therefore, we can say U is equals to minus 40 centimeter, and focal length is also equals to minus 15 centimeter. So calculate what is V. V. Okay. Use the relation 1 by F is equals to 1 by V minus 1 by U. This is the first one. We will get what is V value. We'll get what is the V value. Okay. I hope we can do this. Do this. And in the second case, the object is moved. Moved to a distance of 20 centimeter. Initially, the distance is 40 centimeter. If the object is moved towards the mirror, okay, towards the mirror, no, this is not, sorry, I have drawn the lens. Please think about this. This is the mirror. This is a concave mirror. Please have a look and note down this properly. Properly. Then definitely you can get it. Get it. This is the point. So observe this. This is the second case. It is, let us say, it is U dash. F will never change. Find out what is 1 by V dash. 1 by V dash is equals to 1 by F minus 1 by U dash. Then you will get what is the value of V dash. Therefore, what is the displacement? Okay. Displacement becomes equals to final minus initial. That is, we can say V dash minus V. You calculate, then you will get the answer. Okay. So whenever we do simplification here, then you will get the answer. 36 centimeter away from the mirror. 36 centimeter away from the mirror. That is the basic idea we have to keep. As object move towards the mirror, image will move away from the mirror. That is the logic we have to keep in our mind. So just take the difference between these two cases, V and V dash. Then you will get the displacement of the image. Okay. I hope you can do it. And you will do it. So move the next one. Move on to the next question. What they are saying to us. A concave mirror of focal length F1 is placed at a distance of D from a convex lens of focal length F2. A beam of light coming from infinity and falling on this convex lens and concave mirror conjugation returns to infinity. The distance D must be equal to. Okay. Please observe the question carefully. There is a combination of lens. And there is a concave mirror. Okay. So please have a look here. This is the thing. So what they are saying to us here, please observe this. The F1 focal length, a concave mirror of focal length F1 placed at a distance of D, from a convex lens of focal length F2. So please have a look here. A parallel beam of light coming from infinity Whenever the light is coming from the infinity, it is indicates a parallel beam. Parallel beam. So please look at the board here. A parallel beam of light. A parallel beam of light is incidenting on the lens. Incident on the lens. And according to the question, they are saying that the ray is after reflection from the mirror. After reflection from the mirror okay, it will retrace its path, and it follows to infinity, returns to infinity. So the distance d is equal to so one thing it should be very clear. In order to retrace, okay, observe this, to retrace the rays from the lens, has to incident at the center of curvature, of the concave mirror, center of curvature of a concave mirror. That is only the condition. Which satisfies the given sentence. So this point must be the center of curvature. That is, say, the distance between this and this is r, and we know that r is always equals to 2 times the focal length, and this should be equal to what is the principal focus? The center of curvature. This point will act as center of curvature for the mirror, and the focal length or focal point for the lens, is f2. Therefore, you can say d becomes equals to f2 plus 2f1, f2 plus 2f1. Hence we can select option C as the right answer. Here option C as the right answer. I hope it is clear to you. Please check it. Then definitely you will get 2f1 plus f2, f2, because they are asking about the distance. Okay, I hope you understood this point clearly. So move on to the next question. What they are saying to us. So please read this. Find the value of angle of emergence from the prism. The refractive index of the glass is √3. Angle of emergence is I2. We have to calculate here. So from the figure, I am giving this problem as a homework to you here. I am giving this problem as a homework. I hope you can solve this. From the figure, we can say that I1 is equals to I2. I1 is equals to R1 is equals to 0. R1 is equal to 0. Is it clear? What is the refractive index? They have given refractive index is equals to √3. And we know the relation A is equals to R1 plus R2. Use the relation A is equals to R1 plus R2. And please do simplification. Then definitely you will get the answer. Okay. So observe this. If here this is 60 degree, then angle of prism must be equals to 30 degree. R1 is 0 plus R2, which implies R2 becomes equals to 30 degree. So use the relation N is equals to sine I2 divided by sine R2, and simplify and substitute, and you must get the answer. As 60 degree. Option A will be the right answer. I hope you're understanding these points clearly here. So now let us move on to the next question. What they are saying to us. Which color of the light has the longest wavelength here? Which color of the light has the longest wavelength? We know that. So we can say that lambda r is greater than we can say lambda green greater than the wavelength of the blue greater than wavelength of the violet, wavelength of the violet. Hence we can say red color has the longest wavelength. See how easy the questions are given in the previous year's NEET papers, papers. Okay, if you learn the basics of this particular chapter also, you can easily attend the questions from this particular chapter in the NEET entrance examination. Okay, so move on to the next one. What they are saying to us. Please do this question here. In total internal reflection, when the angle of incidence is equals to critical angle here, when angle of incidence is equals to critical angle, so what will be the angle of refraction? Directly we can say no, angle of refraction must be equal to 90 degree, must be equals to 90 degree. That is option C will be the right answer. Option C will be the right answer. So these are all the questions which are given in the previous year's papers. So we should not neglect any of these things. So please observe this. I hope you can do this here. A convex lens A of focal length 20 centimeter and a concave lens B of focal length 5 centimeter. So therefore observe this. Focal length of the A is plus 20 centimeter according to sign convention. Focal length of the B, since B is a concave lens, so focal length must be minus 5 centimeter, are kept along the same axis with a distance d, d between them, If a parallel beam of light falling on A leaves B as a parallel beam, then the distance DE, D is. Please observe this diagram. So one is of convex lens and other one is of concave lens. Okay, and these two are separated at a distance of D. And what they are saying to us here, the ray which is incidenting parallel to this, the convex lens, okay, is leaving parallel to it, So please observe and look at the board. What is the meaning of this? This combination will act like just a transparent plate, this transparent glass plate. Therefore, we can say that F equivalent must be equal to 0 according to the given sentence. Okay. Therefore, use a relation here. 1 by F equivalent is equals to 1 by F1 plus 1 by F2 minus D divided by F1 into F2. So 1 by 0, okay. Effective focal length, what can you say about the effective focal length here? Effective focal length will be equal to 0. Is it clear? I hope you are understanding and we can do this problem. I hope you can do it. So please think and answer. 1 by, so here I am saying it is a mistake. This is a point here. So please think about this. I have done a wrong diagram also. 1 minute. I'll redraw the diagram. It cannot be F equivalent cannot be equal to 0 here. Because so okay, see here. This is a convex lens and this is a concave lens. A parallel beam of light is made to incident. So please have a look here. Any confusion, you can comment so that I will explain to you. Like this. Is it clear? So whenever we consider a parallel beam of light which is incidenting and emerging as a parallel beam of light, it just act like a glass plate as we discussed previously. Therefore, the effective focal length is not 0. It should be equal to infinity. Focal length must be infinity. It cannot be equal to 0. Okay. So just do simplification now, then you will get the answer here. 1 by infinity is equals to 1 by f1 is 20 plus 1 by f2 is minus 5 minus 5 minus what is the d value here we have to calculate divide by 20 into minus 5 20 into minus 5. So just do simplification. 1 by infinity is 0 now here 0 is equals to 1 by 20 1 by 20 minus 1 by 5 minus 1 by 5 okay plus d divided by plus d divided by 100. So please do simplification. 0 is equals to 20 into 5 is the LCM 5 minus 20 plus d divided by 100. We can say that see here minus 15 divided by 20 into 5 plus d divided by 100. Therefore, d divided by 100 is equals to 15 divided by 5 into 20. 5 1 5 3 5 1 5 3 21 25. Therefore, d becomes equals to 3 into 5 15 centimeter. We will get the answer as 15 centimeter. Hence, we can select option B as the right answer. Option B is the right answer. Okay. I hope you can understand. You can easily calculate here. So there are remaining certain problems. I am giving these problems as a homework. Please do it and simplify this problem by yourself. Okay. Homework. Please do this question. Question. Then you will get option D as a right answer. D as a right answer. Please simplify this question. So move on to the next one. Move on to the next question. What they are saying to us. A lens of large focal length and large aperture is best suited as an objective of an astronomical telescope. Since what they are saying, you observe this. A large aperture contributes the quality and visibility of the images. It is correct. Whenever the aperture is large amount of light will incident and it will produce the intensified image. Okay, so large area of the objective ensures better light gathering power. A large aperture provides a better resolution. That means we can see the image of an object clearly whenever the light enters in a larger amount. Hence, we can go with the option D as the right answer. Okay. So similarly, move on to the next question. What they are saying to us. Please read this. An astronomical telescope has an objective and eyepiece focal length. Objective focal length is 40 centimeter and eyepiece focal length is 4 centimeter. To view an object 200 centimeter away from the objective, that is object distance is given to you minus 200 centimeter. The lens must be separated by a distance. That means we have to calculate what is the L value. Okay. So please do the simplification. What is the thing? What can you say, ma? What can you say about this question? Question? Please read this once and try to answer this question. Question. Okay. So please think and answer. So whenever we observe or whenever we apply the lens formula for telescope, objective lens will have a large focal length and eyepiece will have the less focal length. Okay. So please observe this. 1 by FO is equals to 1 by VO minus 1 by UO. So from this you calculate what is VO. So whenever we do simplification then you should get the answer. Then you will get the answer as 50 centimeter 50 centimeter. So please do simplification. Then exactly you will get the answer here. So observe this. What is the focal length of the eyepiece? Focal length of the eyepiece is equals to, this is the focal length. From here to here it is 4 centimeter they have given, and from here to here it is VO. What is VO value? It is 50 centimeter. Therefore, observe this. What is the length of the tube? The lengths must be separated by a distance. Therefore, L becomes equals to VO plus FE. VO plus FE. L becomes equals to VO is 50 plus FE is 4, which is nothing but 54 centimeter. We will get 54 centimeter. Hence, we can select option C as the right answer. Option C as the right answer. Okay. I hope it is clear to you. So move on to the next question. Move on to the next one. What they are saying to us. Please read this problem here carefully. An astronomical telescope of a tenfold angular magnification, that is magnification is given to you as a 10, has a length of 44 centimeter. L is equals to 44 centimeter. The focal length of the objective is, we have to calculate what is the focal length of the objective. So how can we do this problem here? L is given to you, magnification is also given to you. We know M is equals to FO divided by FE. Therefore, we know what is FE value here? FE is equals to FO divided by M. So FO divided by 10. So L, what is L? L is equals to FO plus FE, my FO plus FE. So just substitute 44 is equals to FO. Let us keep this value as it is. And FE is FO by 10. FO by 10. So whenever we do simplification, 44 is equals to 11 FO divided by 10. So please do simplification here. 11 FO is equals to 440. Therefore, FO becomes equals to 440 divided by 11. So you will get the answer as 40 centimeter. 40 centimeter. Okay. Hence, we can select option C as the right answer. Option C is the right answer. Is it clear? I hope you understood this question clearly. So similarly, let us see. Okay, these are all the questions. These are all the questions which I have considered to explain the chapter Ray Optics and Optical Instruments. Okay, these are all the questions which are given in the previous year's papers also. If you want, you can check it. You can check it. So based on the knowledge what we have discussed in today's lecture, okay, you can solve any question. You can solve any question related to NEET entrance examination. Okay, I hope you will learn these formulas, you will understand these concepts, practice and all those things, and later take any one of the reference book. Or if you solve the previous year's papers also, it is more sufficient to answer the questions from this particular chapter. Okay, I hope you will do this. You will do this. I am sure that you can answer the questions from this particular chapter in the NEET entrance examination. Okay. Yes, with this I am going to end the today's lecture. We will meet you in the next chapter with the wave optics. Until then, please keep preparing. Don't waste your time. Okay. So thank you very much. Bye bye.